Okay, so here is our worked example 4. And it's saying the marks scored by 80 year 1 students at Wells Rock University are shown below. And here are the marks. And then now it's saying represent the data on a histogram. So it's saying you should represent the data on a histogram. Well, first thing you're going to do here when we're representing this data on a histogram is we are going to have to convert this frequency distribution to our histogram table, the table that has frequency density, right? That we can then use to make our to plot our histogram. So first thing is we are going to take this frequency distribution. We know it's a table. We know that frequency distribution is a table which shows you the data, in this case the marks, and the frequency. So what we're going to do now is convert it to our table. What do? We write mark, or marks rather. Should have been marks, I guess. Marks. And then after marks, what is the next one? Boundaries. The next one would be boundaries, right? So we say marks, then boundaries. On boundaries, we have lower class boundary and we have upper class boundary. Then after boundaries, what we want to get is the interval width, because that's the reason why we get boundaries, to get the width, the interval width. Then after that, we put the frequency, and we can then use interval width and frequency to get the frequency density. Okay, I'm going to write it like this: frequency density. So anyway, let's do it. Put my thing like this. Here's another column. Gosh, it's not straight. Here's another column. Here's another column. Here it is. And here it is. And here's another one. I'm just constructing my table. Thank you for your patience. Put this one. We'll go on it like that. Good. Now here it is. So we have our stuff like this. Lower class boundary, upper class. These are boundaries. So now let's go. Marks. We could put it like that if you wanted. Okay. So now let's go. Marks. Remember, they were going like horizontal to say the first one, yeah, then the second, but now we're going down, okay? So we would say 0 to 9, and then we would say 10 to 19, then we'd say 20 to 39, then we'd say 40 to 69. These are the marks. Now let's put the lower class boundary and upper class boundary. Now this is when it gets interesting. Do you know why? It's because if you look at the previous example we did, we had a similar scenario where we didn't have it in interval notation. There are no inequalities here, stuff like this, lower than m, then less than something. If we say 7 less than or equal to m, which is less than 9, then your boundaries are 7 and 9. That's very easy because this is interval notation. You already have the boundaries. You already have the boundaries for your interval. But when I have a dash to say 7 to 9, then you must know that the boundaries, what I actually want here, is from 6.5 to 9.5. That is what I am looking at. Though it says 7 to 9, but we know that we actually are dealing with the range from 6.5 less than or equal to whatever, which is less than 9.5. That's what we are talking about. Those are when we are including the bounds. I'm sure you did bounds in IGCSE maths. So basically now we have it saying 0 to 9, which means we're going to have to convert it. Because when it's like this, remember that we need a continuous scale. You say to me, why do we do that? We need a continuous scale. Remember that our histogram, the bars should be continuous. There should not be any break. So we can't say 0 to 9, okay? We can't say 0 to 9 and then 10 to something, because now there is a gap between 9 and 10. But it has to be continuous. So we can't end at 9, then start at 10. Great. So how do we fix that? Well, in that last example, we were dealing with continuous data where it was measured. Something was measured, and I'm sure they told us to the nearest whatever they said. Okay, so when we are measuring, we saw that we still just say 1/2, we get 0.5, and then whatever that one is, if it's milliliters or whatever, then we add it to the upper bound and reduce it from the lower bound, right? But the other important thing that I want you to remember is when we did continuous data, when we were starting with 0, we did not subtract 0.5 to get negative 0.5. We did not say the first one was on the lower bounds. You can go and check. The lower class boundaries, we said when it starts at 0, we just put 0. But this is not the case for discrete data that we're dealing with right now. Right now, we are dealing with marks. The marks. Do you measure marks or you count marks? You count, isn't it? So marks are discrete because you have 1 mark or 2 marks or 3 marks or 4 marks or 5 or 6 or 7 or 8 or 9 or 10. You have something. Discrete numbers. Now, because we have discrete values for marks, that means that marks, when we are dealing with it, when we are converting it to our continuous scale, we can have negative 0.5. So what we would say is, remember we would say 1 divided by 2 gets 0.5. So what we are doing is we'll be adding 0.5 to the upper bound and removing it from the lower bound. So here, to get the lower class boundary, we say 0 minus 0.5. So 0 minus 0.5, you get negative 0.5. So that means my lower is negative 0.5. Then the upper class boundary will be 9 plus 0.5. It becomes 9.5. You'd be adding. You can do that. Then here, 10 minus 0.5, it is 9.5. 19 plus, because it's the upper bound, we add, plus 0.5, you get 19.5. 20 minus 0.5, you get 19.5 as well. And then 39 plus 0.5, you get 39.5. 40 minus 0.5, you get 39.5. 69 plus 0.5, you get 69.5. Here are my boundaries. Now I can start to calculate the interval width. So the first one is very interesting because we would say, yes, 9.5 minus 0.5, right? Minus negative 0.5, I'm sorry. So it would be 9.5, it's 10. Minus negative 0.5, you get 10. Then the next one would be again 19.5 minus 9.5, which would be 10 again, right? And then for the third one, we would say 39.5 minus 19.5, which in this case would be 20, right? Then for the last one, what would say is 69.5 minus 39.5. And in this case, you'd get 30. Now, we have the interval width. Great. Now we need to put the frequency. And frequency we just take from the table, okay? But we are now doing it going down. So the first one is 8. Next is 11. Next is 33. Next is 28. Now for frequency density, we'll be just saying frequency over width, over interval width. Then you get your frequency density, right? So remember that frequency density is equal to how much, which is frequency, over the space, which is the width, okay? The interval width or the class width, right? So you'd say how much, that's frequency over the width. So it'll be 8 over 10, you'd get 0.8, right? Then you say 11 over 10, we always do that, and you get 1.1. Then you get 33 over 20, right? You can be calculating on your own. I'm just recording the answers for this one. So you'd say 33 over, and you'd get 1.65. Then the last one is 28 over 30. Yes, for this one, you'd get something that is recurring, but we would have, so this one was 1.65. You'd have 0.933, blah, 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 blah. Okay? But what we do is, with these guys, we like to put them to only one decimal place because that is what we can put on the, that is what we can put on our histogram, right? So you would love to round it off. You'd love to round it off to one decimal place. So this 1.65, I would round it off to 1.7. Remember that 5 is because when you're rounding off 1.65, you want to round it off to one decimal place, which means only one number. After the comma, you look at the second one. It's a 5 and above, so we add 1 to the 6, it becomes 7. Then this one 0.93 just becomes 0.9. And these are the ones that we're going to put on the histogram, okay, after rounding off. So I'm going to put them like that. So I can go ahead and construct my histogram now because I have everything I need, and the trick was on the boundaries, okay? Now all we're doing is to plot. So let's go ahead and let's put. So I'm going to put a long line going like this, and then going like this. Then I'm going to put my horizontal like that. This is where my histogram is going to be. Now, either way, you have the place to put your histogram. Don't worry about it. So now I would say, remember what goes on the y-axis is the frequency density all the time. Okay? Remember, it is the frequency density. That is why we calculate it so that we can put it. And then what goes on the x is this first column, which is the marks. So in here, I'm going to have marks, right? Great, going that way. Let's see where to start. Where do our marks start, right? Where do our marks start? What are we going to be plotting? Are we going to be plotting 0 to 9 or negative 0.5 to 9.5? Well, we'll be plotting negative 0.5 to 9.5. That is what we put. I'm sure you still remember that. We put the boundaries. Okay, so the proper ones, the true ones. Now, this is negative 0.5. You say, oh, so where should I start? That means it's going to go to negative like this and start here at negative 0.5 because this is 0. No, you don't have to make the start 0. We could make this position on the y-axis be like negative 0.6. Then we can start going with the rest, okay? Right, or we could have it as negative 1.0, right? So this one is like that. It starts from negative 1.0, and we can start to put our things. So ours is negative 0.5, so we would be like somewhere here, negative 0.5. So this is negative 1.0. And then here it will be 0 for frequency density because our frequency density is just going to be positive, guys. That one you can know. But the horizontal axis, it doesn't have to start at 0. Okay, here we can see it's starting at negative 1.0. Then somewhere here we have our negative 0.5. Right, then it's going up to what? What is negative 0.5 going up to? It is going up to 9.5. So we put it all the way up to here, 9.5. And then from 9.5, it goes to 19.5, which is 10 again. So we can move something that looks like 10. And here we have our 19.5. You actually have opportunity to count because your boxes will be there for you. Then 19.5 goes to 39.5. That's 20 now, so times 2 of it. So it's going to somewhere here to 39.5. Then 39.5 goes to 69.5, which is 30 stuff. So it's going to be the biggest here, going up to 69.5. Now, we put our frequency densities. So we have 0.8, 1.1, 1.7, 0.9. So yes, let's go for it here. What is the highest value here? It is a 1.7. So we can be saying that this is our 0.1, 0.2, 0.3, 0.4, 0.5. So this is 0.5, then 0.6. It's a little bit too far. I'm sorry. 0.5, then 0.6 is here. Right? Is here. Then 0.7, then 0.8, then 0.9. Then here we have our 1.0. Then we have 1.1, 1.2, 1.3, 1.4. Here we have our 1.5, right? And we go 1.6, then 1.7. So now let's put our things. So what are we plotting? We are plotting the first one is 0.8. So it'll be going to 0.8. So 0.5, 0.6, 0.7, 0.8. 0.8 starts at negative 0.5. So it is a 0.8. Then it goes to be down to this guy. There we have it. So this is going to be our first one. So it goes all the way to 0.8, then horizontal, then we're gonna have this guy straight. So this is the first one. Great. Now we can keep going. Okay, we keep going. We stop at the rest and we keep going. Okay. So great. What is the next one? It is 1.1. So 1.1, we go 1.1. So I'm going to elongate it until it gets to 1.1 here. Okay, we can see that here. So I can pull it up a bit. Then we take this to 1.1 as well. Then we can join them. All right. Now, what is the next one? It is going to be, I'm looking in this side, 1.7. That's where I'm looking. So it's going to be 1.5, 1.6, 1.7. So it's going all the way to the top there. Okay, this is like my 1.7 up here. So let me pull it up there. Then we can have this go as well to 1.7. Then we can join them. Great. Then now we have 0.9. One, just a little bit before one here is going to be our 0.9. We can go with it like this. I'm going to erase at the end. Here is my 0.9. So I'm going to go with this up to here. Join it. Okay. Here is my 0.9. And here is your histogram plot, and you are done. But remember to put the heading. Don't forget the heading. What is this histogram for? We always want to know. So what is it showing here? We know that it is showing the mark scored by 80 students. So we can just say histogram to show at Walmart University. Okay, histogram to show the marks scored by students at Walmart, whatever, at Wells Rock, sorry. Marks scored by students at Wells Rock University, okay? At Wells Rock University. This is the end, and here we have our histogram, and we are done. So I hope you saw the tricks and the things we did, and you should be able to master. Okay, we'll do many more questions on a nice graph pad this time. All right, but that's it. Goodbye for now.